Hey everyone, Happy New Year! Wow, it's 2021. I can't believe it. Okay, welcome back. Let me remind you, we were talking about covalent bonds when before winter break, and so now we're actually going to dive into a different type of bond that is called ionic bonding. And so you'll probably remember in covalent bonding, we had our atoms sharing their valence electrons. So let me show you this image here. Okay, so we've learned how to draw Bohr diagrams that look like this and how to predict how many bonds different atoms will make based on how many valence electrons they need in order to complete their valence shell, right? They want a full valence shell, which is 8 electrons in that outer energy level. Okay, so in covalent bonding, they share electrons. Let's look at ionic bonding. Ionic bonding results in really beautiful crystal structures that look like this. And so you guys have probably seen crystals. Any crystal that you see, like a quartz crystal, some of you might have like a necklace or jewelry made out of crystals that have that really beautiful shape. They form because of the molecular structure and because of ionic bonding. And so you probably are going to recognize this word right here, which is ion. And in one of our previous activities, we learned about ions, and you saw that ions have a charge on them. So it's an atom, but they have either a positive or a negative charge. And so we're going to learn about the two types of ions that can form and what negative and positive ions are called, and then how they form these structures. And you're probably going to notice in this molecular structure, it's a really perfectly, all the atoms are perfectly lined up. You'll notice the green ones are negatively charged. This is a chloride ion. And so those all have their negative charges. And then the yellow or orange ones are sodium ions, and they have their positive charges. And notice they go back and forth. Negative, positive, negative, positive, negative, positive, negative, right? Just back and forth, and it forms this lattice, which is what results in this crystal structure that's so perfect. So our learning objectives for today are to, one, explain the atoms gain or lose electrons to form ions, so they have a full valence shell, which makes them more stable. So you'll remember from I'm going to say last week, but last time we were together, we talked about what it means to be stable and how atoms, just like we have our 2 feet on the ground, right, and we're very stable, or even if we're laying down, we're even more stable, but atoms also want to be in a stable position. And so they need to surround themselves with a full valence shell of electrons. So our next learning objective is to explain that ionic bonds are electrostatic attractions between cations and anions. And so electrostatic, what does that mean? So this word means electricity, right? That's that first part of the word. Static, you can kind of think of like even when your clothes are staticky, right? And they stick to each other. So it's this electricity, like static. Maybe even at night, if you have a little bit of static, you can see a spark between like your clothes, right? If you're doing laundry at night, that I've seen that before. That is because ions are literally causing static, and then it causes this attraction between the positive and negative atoms, right? The positive and negative ions. And so that's what we call cations and anions, and I'll explain those in a minute. And then next we're going to describe how the structures of ionic compounds affect their properties. So we'll talk about that probably next week. We're going to look at naming, and this will be in the weeks to come. Okay, so ions and the octet rule. The octet rule here still applies, just like it does with covalent bonds. So all atoms want to have a full energy level. Now the problem you'll notice is that, like, for example, let's look at magnesium, since that's what's here. It only has 2 valence electrons. So it's going to need to make a lot of bonds or get a lot more electrons in order to complete its valence shell, right? And it's not going to make 6 bonds with another atom. So I'm going to explain in the next video how magnesium becomes an ion and forms an ionic bond instead of forming 6 bonds with another atom. All right, please watch the next video.